So I have the formal introduction, which Jeanne just told me to go rogue with, so I'm going to do exactly that. It's really, truly a pleasure to introduce Dr. Jeanne Marrazzo, who is the current director of the National Institutes of Allergy and Infectious Diseases at the National Institutes of Health as our current Merigan lectureship. Prior to recently taking those rather big shoes to fill, Jeanne was the chief of ID at the University of Alabama, Birmingham. And before that, she was at the University of Washington, where our paths crossed. She's an outstanding clinician, teacher, mentor, educator, really the whole package. Just to tell a few little stories from my time with her, since I'm now going rogue and making this up as I go. Actually, Jeanne is the reason I'm an infectious disease doctor. She was my first attending on my internal medicine clerkships when I came back after my PhD to go back to medical school. And her brilliance, her ability to care for her patients, pretty much everything. I basically just decided I wanted to be Jeanne for the rest of my life. And that's exactly what I did. We also spent many years when I then became a fellow trying to stump her with clinical cases. We would present mystery cases, the hardest ones we could find. And we've never managed to do it in all those years. And I was a fellow for a really long time, for those of you who don't know. So it took a while. So Jeanne's research really has focused on a wide variety of things, including sexually transmitted infections. She's done clinical trials from gonococcal diseases. She's worked on HIV prevention and really insightful work on the vaginal microbiome and its impact on health. She's led multiple large NIH clinical trials. She has a list of awards that she forbade me from giving, but it's very long. And really with that, it's my pleasure to introduce my colleague, friend, mentor, who's always there for me, Jeanne Marrazzo.
Thank you. All right. Well, can you guys hear me okay? Is this on? So Catherine told me she was afraid she might break into tears when she was introducing me. And in fact, I was tearing up when she was introducing me. So to say it's an honor to be here is really an understatement. People often say they're humbled by introductions, but I really, really, really feel humbled. It's also an incredible honor to be here to recognize Dr. Merigan. What a giant, what an amazing role model, someone who changed the field in an infectious disease that has had a huge part of my career. When I was reading about you, Dr. Merigan, I saw that it was estimated that your papers were cited over 45,000 times. And when I read that, I thought, I don't need to be nervous about this talk because I'm never going to live up to anything that Dr. Merigan did. So I might as well just relax and have fun. So that's what I'm going to do today. So it's tough to put together a talk for this amazing, diverse, accomplished audience. But here's what I'm going to try. And I'm really going to hope to have some time for questions at the end. I'm going to talk a little bit about how I got to NIAID. And then I'm going to move to some challenges that I think the field is trying to address and will need to address in the next 5 to 10 years. And then some opportunities I think we have to change things. So very fittingly, Dr. Michelle Berry just walked in because Michelle had a huge also role in my development professionally. I was a fellow in infectious diseases at Yale New Haven Hospital, which is where I met Dr. Berry. And that was in the early days of the HIV epidemic. And I was fortunate there to meet many strong educators with a very big commitment to academics and to public health. So that sort of nexus and overlap of those worlds, which you really don't often get, as Catherine mentioned, when you're a trainee, was very strongly supported there. We had many, many diverse patients dying with HIV at the time. New Haven was a microcosm really and represented a lot of what we would see subsequently and we're seeing in sub-Saharan Africa, a lot of women infected by sex partners, by injection drug use. And so I really got interested in women's health and infectious diseases. And it also became clear that we had to be advocates for our patients, right? Our patients, at that time, there was still a ton of stigma. Of course, there still is, having lived in Alabama for 7 years. I'm happy to talk about that. But the stigma then was really profound. And so you really couldn't take care of these patients without becoming scientifically and politically an advocate for them. So that made a lot of sense to me. And to be honest, I always wanted to be a bit of a rabble-rouser outsider with an inside track. And that was, I didn't realize that till much later, but I really didn't have a lot of patience for really a lot of the hierarchy that I saw in academic medicine. So went into infectious diseases and particularly sexually transmitted infection and HIV because the role models there really spoke to me, and really it seemed like a place that I could really make a difference. So I ended up going to the University of Washington, which where I did my fellowship and then stayed for a very long time, and then moved in 2016 to the UAB to take over the division of directorship there. And I'll just very briefly touch on some of the research that got me where I am and why I think some of it is still so important. I started out, as shown here, working with the many folks there who were doing sexually transmitted infection research. But then I got very interested in vaginal infections because really nobody cared about it. The only people who knew anything about vaginal infections were the OBGYNs. And even they were not really kind of in the NIH research world. So I thought it was an opportunity, not just for the pathophysiology, the infectiousness, the virology, all that very interesting stuff, the immunology. Nobody knew anything at that point about female immunology, the female genital tract mucosal immune system. And so it turned out to be a very good thing. And as in all things, being open to collaboration and creativity in research is really what it's all about. It's also about paying attention to your gut. So when I was a fellow, I was working on chlamydia, selective screening, diagnosis. I was working with Walt Stam, King Holmes, you know, and I kind of liked it. It was fine, but I didn't find it particularly creative, to be honest. I mean, it was work that had to be done and it was really cool, but it wasn't, to my mind, as exploratory as what I really wanted to do. And I had a good friend in New Haven who called me when I was a fellow and said, you know, I really don't know what to do. I just found out I have cervical cancer and I have to have surgery. And I said, well, what's the problem? She said, well, I've never had sex with men. I don't know. I know this is a sexually transmitted condition. I know it's caused by HPV, but I don't understand how I could have gotten this. So long story short, I persuaded some very generous mentors, including Denise Galloway and Laura Kautsky in particular, who you may know led the vaccine trial that gave us the first HPV vaccine, with Denise having a huge role in defining the structural components of that virus that led to the HPV vaccine. So they very kindly allowed me and facilitated my enrolling a cohort of women who were very similar to my friend. Long story short, what we found was that there was a very high frequency of oncogenic HPV infection in these women. And it really didn't matter whether they had had a history of sex with men or not. And they were very clearly transmitting this virus. Moreover, in a whole suite of studies that we did later, we showed that most of them were not getting pap smears because the message was that they didn't need them, and they really, quote unquote, didn't need to see a gynecologist because they didn't need birth control. So it was a very interesting sequence of events that all came from a phone call, and all came from me being persistent and saying, you know what, there's something here. You can't just ignore this group of people, and you can't ignore that people are behaving in ways that sometimes you don't know about because you are not them, which was, you know, shocking, and which we knew from HIV, of course, in a much more tragic way with men who have sex with men. So that led me down this path of people started calling me with questions about this, and I started hearing that this group of women had a very high prevalence of bacterial vaginosis. And if you don't know what that is, that's when your vagina goes rogue, speaking of rogue, Catherine. Instead of being dominated by a very, very important Lactobacillus crispatus species, it becomes essentially taken over by commensal anaerobes and a very diverse array of anaerobes. I'll talk about why that's important in a minute. But we never really knew what was causing this condition. We still thought it was maybe a sexually transmitted condition, infection. We really didn't know. Anyway, people were saying that this group of women who had sex with women had a very high prevalence of bacterial vaginosis, which made no sense because they didn't have a high prevalence of any other STD except for the HPV. I mentioned chlamydia, gonorrhea, they weren't really happening. So what we did was in our cohort study enroll a group of couples, and we looked at monogamous couples, women who had been together for at least 8 months. And we showed using, again, generously supplied materials, labor, et cetera, speaking of mentors from Sharon Hillier, who by that time had moved to Pittsburgh from the University of Washington and had developed a rep PCR to fingerprint this isolates, that if you looked at couples, they had exactly the same isolates. So they were clearly sharing their vaginal microbiome. And why was that important? Well, to my knowledge, it's one of the first times. I never like to say the first because you never really know what other people have done. But I think it was one of the first times that we really pretty much proved that dysbiosis could be an infectious disease, right? And that it could also be altered by the introduction of other bacteria into environmental niches, which we now do, right, with fecal microbiome transplant. And we're actually starting to do with vaginal microbiome transplants. Caroline Mitchell is working on that at Mass General right now. So that's going to be a really interesting thing. So again, a story where you just keep going down this road and you never really know what's going to happen. There was no guarantee. And many people thought this was really not that interesting because it was kind of like, why would you bother? So why do you care about this dysbiosis? For those of you who don't know, and this is where having colleagues in obstetrics in particular and gynecology, speaking of interdisciplinary richness in research careers, was so important because they were among the first people to really start looking at cohort studies showing that when women have this disrupted microbiome, i.e. lactobacillus paucity, crispatus paucity, they are much more likely to have acquisition and transmission of some very nasty players, including HIV, chlamydia, gonorrhea, trich, mycoplasma genitalium, et cetera. And it's not a good thing to have in pregnancy. So the estimate is that bacterial vaginosis probably accounts for between 11 and 15% of all preterm births, if you look at the attributable risk. Also associated strongly with low birth weight, amnionitis, chorioamnionitis, endometritis, and post-abortion PID. So it is basically a signal that you have probably not just had overgrowth of these bacteria in the vagina, but you have also modified the sort of surveillant immunity at the cervical interface. So you're really allowing these bacteria to ascend into the upper tract. And obviously, if you're pregnant, that is not a good thing. I could talk about that for a long time, but I will move on because I have a lot more I want to say. And I will not bore you with tales of the vagina for 45 minutes. Fast forward, I mentioned in that slide that HIV was one of the things that people were identifying as a consequence of having this these bacterial communities. And one of the first studies I'm showing here is out of Doug Kwan's lab at Harvard, where they took advantage of samples that were collected as part of something called the FRESH cohort. FRESH cohort was done in South Africa, in KwaZulu-Natal, and they enrolled several hundred young women, 18 to 24, and followed them over the course of a year. This was before HIV pre-exposure prophylaxis was available, unfortunately. So the incidence of HIV in these young women was over 8%, which unfortunately we're not seeing a gigantic decline in. But what they had in this group of women was samples of vaginal fluid at enrollment into the study. And what you're seeing here, you can see my cursor, is a sort of a definition or a description of the vaginal microbiome going from lactobacillus crispatus predominance here, and then into, which is the ideal state, then into sort of this transitional state, which we think of as something that goes between the anaerobe predominance and the lactobacillus predominance. This is often predominated by lactobacillus inners, which we don't really understand. And then here getting more and more diverse, and then ultimately this community type 4, which is their designation for what was the most diverse population. And I should add, I didn't mention this, but one of the reasons I got into this is because of my collaborations with David Fredericks, who of course is a Stanford alum and came out of David Relman's lab. And David and I did a lot of this work together, which really changed my life in many ways. But I want you to look at the HIV incidence over here by this community subtype. So you can see that although not a lot of these young women had a lactobacillus crispatus predominant environment, those that did not acquire HIV at all. Those who had lactobacillus inners predominance did acquire HIV, with 9% of them getting it. And then as you look into the more diverse groups, it was 10 to 12%. Now, this group, again, these are not gigantic numbers, but they were able to control for acquisition of chlamydia, gonorrhea, syphilis, trichomonas, and these relationships held no matter what you did. They also replicated this in a mouse model. It's not a great model for vaginal microbiome and related physiology, but they showed that immune changes were strongly correlated with this shift. So it's not just a matter of not having the lactobacillus, it's probably a matter of other things going on. So it clearly is a risk. So fast forward to this, why am I going here? So by the time that the fresh cohort came out, and by the time that David and I and our group had published a lot of papers on the vaginal microbiome, I had also gotten interested increasingly in biomedical prevention of HIV infection. And you may remember in the mid-2000s, Bob Grant was starting the IPREC study looking at oral tenofovir for tenofovir-based PrEP for men who have sex with men. And a number of studies started around that time, capitalizing on the observation that it seemed that intermittent or continuous tenofovir could be a great way to chemoprophylax against HIV acquisition. Everybody was looking at oral interventions, except for Sharon Hillier and her group in the Microbicide Trials Network, who were designing a very large study that was not only going to look at oral tenofovir prophylaxis, pre-exposure prophylaxis, but vaginal as well. And they had developed a vaginal gel with tenofovir to evaluate it. I'm obviously giving you the punchline here. This was a study that I led with Mike Turengi at the University of Zimbabwe. And we screened over 12,000 women in Uganda, South Africa, Malawi, and Zimbabwe to enroll a little over 5,000 women. We randomized them to those 5 arms, which was oral TDF FDC or Truvada, oral placebo, tenofovir gel, and placebo gel. And women were asked to use these products on a daily basis. As you can see, there was absolutely no effect, and this was a gigantic disappointment because at this point, the IPREC study had already shown an effect, and Connie Kellum, Jared Baton's study, the Partners PrEP study in couples in Uganda and Kenya had shown excellent efficacy of tenofovir pre-exposure prophylaxis, not just in the men, but in the women. So what was going on here? What was going on here was that the women essentially were not taking the product. So when you looked at the biomarkers of adherence at sort of maybe month 3, about 30% of women had evidence of taking any product. You might say, well, then why did you continue the study? Because we asked women whether they were taking the product, and we asked them in many ways that we had worked very hard on to try to get robust assessments of adherence. And basically, women lied. Why did they lie? They wanted to stay in the study. Why did they want to stay in the study? Because they got great care, they got contraception, and they got STI screening and treatment. And what was really important to them was really not HIV pre-exposure prophylaxis. It did not speak to them in their lives. And I'm telling you all this because we did a number of focus groups with the participants. We actually went back and showed them their data, where we showed them where they said they had taken it, and then we showed them their drug levels, and it was 0. So, and not in a confrontational way, of course. I mean, really in a way to try to learn more. So, of course, it took me a long time to get over my incredible depression about this, but ultimately, I actually think this was probably one of the most important studies in the prevention pantheon. Why? Because we don't do these studies anymore without real-time assessment of adherence. And almost any study you do in a healthy population that doesn't really maybe understand the long-term benefits or even the medium-term benefits of the intervention, you really, really need to understand if they're taking the product and what their motivations are. So I often think of myself as a converted biobehavioralist because I really am firmly grounded in biomedical prevention, but we really can't ignore this. I mean, we know this right from the last 5 years. So the other thing I want to mention is that, again, lessons learned, you got to keep your head up and you got to keep asking questions, because boy, did I feel like putting my head in the ground after that study. We not only worked very hard to figure out what had happened with the participants and why they hadn't taken the products, but we also knew we had a responsibility to use some of the biosamples that we had obtained. And what would we want to look at? Well, given my interest and given David Frederick's interests and others, we very much wanted to look at whether, again, dysbiosis in that large, much more recent study predicted HIV acquisition. Not only did we show that, and I'll show you here, these are the women who acquired HIV. Unfortunately, because people weren't taking the product, we had a very high rate of HIV acquisition. And so we saw a lot of cases, over 300. And you can see in the cases here versus the controls that there were quite a lot more women in the cases who had, relatively speaking, who had lactobacillus predominance, and diversity was much more represented in the cases as well. I may have said that opposite, more lactobacillus crispatus in the controls, relatively speaking. You can't tell that from this diagram, but when you do, as Barb Richardson did, our mutual colleague and biostatistician magician, a very sophisticated analysis of individual bacteria, you find some really interesting things. What we were able to do was to look at tertiles of these bacteria, which of course represent relative quantities. And not only were we able to show that several of these anaerobes independently and collaboratively increased the risk of HIV acquisition, for the first time in any study, we were able to show that women with the highest rates, highest quantities of lactobacillus crispatus had a significantly reduced risk, actually about 30% of HIV acquisition. So other studies had shown that the anaerobes individually did this, but just were not powered enough to show this. So again, making lemonade from lemons and really sort of keeping going, you can get a lot of information about from quote unquote negative studies if you continue to really try to keep the intellectual questions going. So really nice. The last slide I'm going to show about my work is this. This was my last R1 before I started doing more administrative work. I also have been really interested in, well, how could you change this, right? If you need lactobacillus crispatus, we've had some interesting lactobacillus crispatus replacement approaches. You may have seen there's a capsule called Lactin V. The Gates Foundation now has a product that they are looking at, trying to sort of change the microbiome. I don't think it's going to be as easy as some people think, but we can talk about that if we had time. I was interested in looking at something called a vaginal contraceptive ring. It's a NuvaRing. Many of you know about this. It's been around for a really long time. It's an interesting ring because not only does it have progesterone, which is the contraception, but it has estrogen. And the idea behind this is that if you use it for 3 weeks and you remove it for a week, you actually menstruate as you're supposed to, quote unquote, menstruate. But we were interested in a couple of things about this. One, these lactobacilli love estrogen. Estrogen is great for the vaginal epithelium. It really creates a great glycogen source. It's just a very good environment. And the other thing is you could use this product if you left it in all month and you would never menstruate. Menstruation is not good for the vaginal microbiome. Gardnerella vaginalis loves heme. It introduces a pH, that's sort of a pH challenge. So what we did was to randomize women in Kenya who were looking for contraception to either cyclic or continuous use of this ring, with the idea that if you did cyclic use, meaning 3 weeks in, 1 week out, you were still providing a good environment for the Lactobacillus crispatus. But if you did continuous use, you were not only doing that, you were preventing them from menstruating, which could be an additional benefit. And long story short, we haven't published this because pandemic. And even I have papers that I like, really good papers that I should be writing, just for those of you who have issues writing papers. So every time I present this, I promise to go home and write it, but I haven't yet. The bottom line I'll show you is that continuous CVR use was not, continuous use of the ring over 6 months, by the way, I should say, was not only associated with really profound log reductions in these anaerobes, but a marked increase in Lactobacillus crispatus, which had not been shown before. So why is this important? Because we really need lots of interventions for women in particular for HIV prevention, and they need to fit into women's lives. They need to fit into their reproductive health needs, and they need to fit into just their sociocultural and biobehavioral sort of situations. So people are putting rings together, all kinds of rings with antiretrovirals and hormones. And if you're going to use a ring, people are using progesterone rings alone. I'm not sure that's like the best thing. Why not use something that is going to be not just contraceptive, but that's also going to be very positive for the vaginal microbiome? So my last slide just says that, and for those of you who are considering leadership jobs, you don't have to stop doing research, really. You can continue to do really interesting work with great colleagues. So don't be deterred by fear of taking leadership jobs, because they will help you and you can have a lot of impact. This is a paper that we just published last month in JAMA, and coming back to choices, this is just a good reminder that people need choices for everything. This was a study that took advantage of demonstration projects in many countries, and enrolled over 6,000 women, and everybody was offered daily PrEP with TDF, FTC, or Truvada. And what we ended up showing was that, number one, women, again, were not truthful about what they were doing. So the pressure for people to tell you that they are doing what you want them to do is huge, even in a demonstration project. This wasn't even a randomized controlled trial. So we did have biomarkers of adherence, which were directly contradicted by women's self-report. So do not underestimate with your patients, as you never should, and I know we never do, although I am guilty of having done it, really how much they want to please us. They really, really do. There's a social norm for this. But what we did manage to do with a very sophisticated statistical modeling that my colleagues did was to show, even in this giant demonstration project of 6,000 people from India, Kenya, South Africa, Uganda, the US, that consistent daily use, defined as 4 pills a week or more, was associated with no infections. Sorry, consistent daily was 7, but consistently high use, 4 to 6 pills a week, was associated with just 1 infection, incredibly low rates of HIV acquisition. So I bring this up because women have been getting a lot of messages about oral PrEP, basically that they have to take it every day, they have to start it 3 weeks before they have sex, which is completely ridiculous. I think women are smart enough to know when to use PrEP. And I suspect that these women who were using it consistently, highly, were actually timing their PrEP around exposure. Go figure. I mean, it's really like, so I think we have to really listen again to what people are saying. And this has sparked some interest, I think, in trying to look at event-driven oral PrEP for women, which we know works very well for men who have sex with men. Okay, so enough about me. I like the way they just my team just grayed out UW and UAB there. And now I am at NIAID, and I did begin my tenure as the 6th director in the fall. I'm shown there with Monica Bertagnoli, who's really fantastic, our new director, and my wife, Jo Hoffman, without whom I would not be here. I'm gonna shift now for the last part of the talk to talk about some things that just in my last not even 6 months, I think have really crystallized for me as challenges in ID research. And just a reminder, NIAID has campuses at the Rocky Mountain Labs, which are shown there. Many of you have been there. That's the main campus, and Building 40 is where our vaccine research center is. So it's really quite an incredible place. I don't need to tell this group, but I will for those of you who may not be aware that infectious diseases remain really the things that should be keeping us up at night. Certainly they keep me up at night. There are outbreaks in the United States and multiple other countries, some of which I'm going to go into, but are all shown there that are very concerning. And then, of course, outbreaks outside the United States, which are shown here. And I think one of the biggest themes, in addition to climate change, which I'll talk about in a minute, is zoonotic spillover. And it's estimated that approximately 75% of emerging pathogens are zoonotic. What a great time to talk about highly pathogenic avian influenza in dairy herds. What's going on right now, right? So we've now confirmed this in several states. It's an H5N1 clade 2344B virus, clearly originated from wild birds. Unfortunately, is now infecting cats. It's infecting paradomestic birds, meaning pigeons, crows, grackles. And there is a confirmed human case of conjunctivitis, although from what I understand, there probably are more. And remember, one of the challenges here where politics, science, and economics intersect is that many of the workers on farms like this are very likely undocumented people, quote unquote, who are going to be very unenthusiastic about getting screened. Also, huge economic pressures, right? Not to disrupt the system here. And so it's been a busy couple of weeks around this. I think it's going to get busier. And so we have a lot going on at NIAID that we can talk about if we have time. But I think this is extremely concerning. We know that this virus has done lots of interesting things and is going to continue to be interesting. So what we are stressing at NIAID really is just a few things, and I'll talk a little bit about pandemic preparedness. When you think about preparedness, the reason we have been so successful in the last several years in getting products out of the laboratory, and I'm mostly talking about RSV vaccine as well as SARS-CoV-2 vaccines, is that we have this amazing background of HIV-related research, which created a structural biology powerhouse opportunity at the VRC. Incredible people working in immunologic diseases, and then those of us who are more pathogen focused. So all of these things really have come together and continue to inform what I hope is a very high level of preparedness. So we have a few things going on, and we do have a nice pandemic preparedness plan that's shown there. But the ideal is really to shorten the time between an outbreak onset and authorization of countermeasures. So medical countermeasures is another term I've learned since I became a Fed. I've learned so many terms. They include antimicrobials, monoclonal antibodies, and of course, vaccines. So we have a very interesting prototype and priority pathogen approach to characterize these potential pathogens. And basically what that means, put very simplistically, is that you don't need to develop tools for every single virus in every single family. What you really want to do is to choose representative pathogens from given families and try to make sure you are as prepared as possible with the medical countermeasures you can have. Surveillance is critical. And then we really need to make sure we have the infrastructure to get whatever we do made and out there to people, which is much more challenging than people realize. So these are just a couple of our programs. Some of you may know we've got the REVAMP, which is research and development of vaccine and monoclonals for pandemic preparedness. PREMISE is a very, very cool project led by Danny Dueck at the VRC, which is a pathogen agnostic anticipatory reagent and countermeasure program. What does that mean? There are surveillance efforts all over the world to find emerging viruses and to identify antibodies that are protective. So essentially, you've got a boutique collection of antibodies on the shelf to a wide array of pathogens that if something becomes concerning, you can just pull out. And then, of course, the AVID program, which is an antiviral program for pandemics. I kind of like it. I feel like I'm getting phototherapy. I'm not living in Seattle anymore, just FYI. A couple of really big challenges I will just mention very quickly because I do want to save some time for questions. Certainly, those of you who work in ID know that antimicrobial resistance is huge. And if you look at the statistics, deaths from antimicrobially resistant pathogens in 2019 were nearly the same as those from HIV and malaria. And of course, they rose during COVID. Why? Because everybody got tons of antibiotics during COVID, right? They were in the hospital, they were really sick. They got infections, nosocomial infections, but they also had lots of empiric presumptive use. So this is a really big challenge for many reasons. They're not easy to study. It's not like it's easy to enroll people in cohort studies of these infections. We don't have great diagnostics to identify these pathogens. And huge problem, limited market incentive, right, for new antibiotics. These are not going to be blockbuster drugs like Wegovy. I mean, this is not going to be anything that's going to increase people's stock portfolio gigantically. I'm going to just skip that slide. So just to let you know, we do have a number of programs and initiatives in this that range from looking at Clostridium difficile to looking at vaccines for selecting enteric pathogens. I'm kind of concerned about what's going on with Shigella in particular, lots of resistance there. There are combating antibiotic-resistant bacteria interdisciplinary research units, and many of you know about the ARLG led by Vance Fowler at Duke, which is the antibiotic resistance leadership group. And they've done some beautiful studies, including leading something that I know you are all familiar with, which is exploring bacteriophage therapy for our most resistant pathogens. And we are looking at that specifically in people who have cystic fibrosis, given the chronic colonization with Pseudomonas aeruginosa, and the likelihood that they are going to get infected or evolve to have antimicrobial resistance Pseudomonas. And then one thing I want to mention is that I, as Catherine, I hope communicated, is that I have been very, very committed to mentoring my whole career. And it's been very concerning to me, which I have a slide on later, to see what's happening to our pipeline. So I feel like it's incredibly important not just to have more generic support for people who are emerging in our field, but to really capture people with the needs of specific problems. So this is a great program, I think, that is embedded in the antibiotic resistance leadership group, where early stage investigators are supported and can do work in this space. And a number of our networks, including the HIV networks, the Infectious Disease Clinical Research Consortium, which have the vaccine treatment and evaluation units, have used this model, and it's a fantastic way to, again, keep people, get modest support. It's not getting in K necessarily, but it can actually be pretty close. So really nice opportunities. I mentioned too, I have to say my team helped put these together, so they kept putting things that I was an author on the slide. So I don't want to take credit for all this, but they were very serious about promoting me. So I want to mention this issue of industry involvement. So getting these products over the finish line is really hard. So here's a great example. NIAID partnered with a pharmaceutical company to bring a product called zoliflodacin, which is a new novel mechanism of action antibiotic against gonorrhea that we got through a phase 2 trial, which is shown there. Stephanie Taylor authored that in the New England Journal of Medicine. But after that, where does it go? We don't support gigantic phase 3 trials generally, although we have done 2B3 sort of things. But what was really cool about this is that we work with GARD-P. Some of you know that's the Global Antibiotic Resistance Group, in partnership with something called Inovia Specialty Therapeutics. This is largely a sort of publicly supported consortium, similar to some of the other organizations that have supported AIDS vaccine research, malaria, medicines for malaria, all of these things. So this group essentially took over the product and funded and conducted a phase 3 clinical trial, which was the press release was released in November 2023. We haven't seen the data. I assume it will come out at ID Week, I hope, showing that in fact in this large international phase 3 trial, this product was safe and effective for uncomplicated urogenital gonorrhea. So just a point that you can do a lot with NIH funding, you can do a lot with us, but we really need partners internationally to get this stuff to move where we need it to move. A couple of other things: combating fungal diseases, really concerned about Candida auris. How could you not be concerned? Concerned about the effect of climate change on increasing infections. I know you all are Coxie Haven here. So I did want to point out that we do have a strategic plan for research to develop a valley fever vaccine, which was published actually not a little over a year ago. But this is still a really big area of interest and concern. And just a reminder that we do fund collaborative research centers in this space to investigate some of the challenges with this persistently challenging disease. One of the most amazing things about being at NIH is that I round at the clinical center at least once a week, sometimes twice a week if I can. A couple of surprises about that. One has been that I thought when I went to Alabama, I saw a lot of late stage HIV presentations. I also see them at NIH because they get referred from DC, and that's really striking. Didn't see them so much in Seattle. The other interesting thing is that we see, of course, people who have the most bizarre presentations of diseases that are common or common-ish. So for example, we have a patient right now who has Coxie in practically every bone of their body, and there clearly is something going on with that person's ability to control the infection. So we're working on that. So it's very exciting. And just a reminder that this August, we with the FDA and CDC are planning a workshop on valley fever vaccine. Okay, so in the last 5 minutes, I just want to come back to this concept of our pipeline. So all of this is fantastic, but none of it happens without a really committed, vibrant, talented, growing pool of people. And by that, I mean not just primary investigators or principal investigators, but all the people we work with, from the lab techs to the clinical trial operations people, to the people who take care of our participants, to the data people, to the biostatisticians. It's really huge. So when I say pipeline of researchers, I don't just mean infectious disease fellows, although of course I am I do have a soft spot in my heart for them. So when you think of that, I sort of put things in these buckets. They're not mutually exclusive. I've already talked about pandemic preparedness. I'll say a little bit about HIV-related research. The research infrastructure has to support these folks. Allergy and immunology fundamentally is really important to think about. And then I think that diversity, equity, inclusion, and accessibility is incredibly critical for reasons that I will talk about in a second. So this is imperative, right? Because our investigator pipeline, and again, I'm going to talk mostly about now here potential PIs, but we know that 67% of our positions in fellowship were filled in 2023. Now we have more programs, so some of it is probably not as dire as it looks, but really fantastic programs have not filled. We didn't fill at NIH for the very first time in history last year. We also know that the number of NIH-supported postdoctoral scholars, PhDs, is declining, and the number of US citizens and permanent resident biological biomedical postdoctoral scholars is declining. So I think these are things that we really have to pay attention to. And one thing I hope I will be conveying in the coming months is some success in our attending to the NIAID training budget. This is one of my first priorities when I got there, because we really had slipped behind. We're behind other institutes. And you all know people who have written their K awards, 2 times and don't get their K. And it's like, we just can't have that when we have really good people, right? So the ideal here is going to be to increase our success rates to 40% or higher for the awards shown there, to maintain our innovative T32 programs. We are going to increase K award salaries commensurate with what is planned for postdocs, which will be good. And we now have, I convened a training working group to assess this portfolio annually. They reported back to me last weekend. I can say we're making really good progress. So I'm really hopeful that the next time we see each other, I'll have even better news. So last, some opportunities, and I just want to finish on some incredibly high and exciting notes. All of you know that malaria remains an incredibly persistent public health threat. We have some nice new vaccines, but they are modestly effective, right? I would say they're not optimal. They are a quiver, an arrow in the quiver. And we really need new malaria prevention tools. And you can see that deaths by world region shown there actually increased in 2020. So I think many of you are familiar with this, but I love the story of these two monoclonal antibodies. These did come out of NIAID and the Vaccine Research Center, of course, with work with many other people in the field. The CIS43LS is a monoclonal antibody to a highly conserved circumsporozoite protein. And what we know about this is that this basically prevents the circumsporozoite or the sporozoite from invading the liver. So it's the pre-erythrocyte phase. So you can actually effectively, with this monoclonal antibody, shut down infection before it's even established. It's a very, very safe and was highly protective against malaria infection in Malian adults. And that slide on the right, or that picture on the right, basically shows, looking at 3 doses versus placebo, that there was really excellent protection against infection. And this was looking every 2 weeks at blood smears on these people who were enrolled. I will say this was a first generation, or is a first generation antibody that required being given intravenously. So not a particularly practical approach for global regional control, right? Well, what do? You design something that's better, right? That's the next step. So the next step is to look at L9LS, which is an antibody that's 2 to 3 times more potent, works similarly, but also probably has some effect on in the sinusoids of the liver. So you may even get some intrahepatic action going on. So this is really a next generation monoclonal antibody. And these are data shown from a controlled human infection model in a much smaller group of people, given the antibody IV or subcutaneously, which is much more appealing, right? If you're thinking about using this on a seasonal, regional basis, which is really how these things would be used, designed in concert with the vaccines. This did very well. So I'm incredibly hopeful that in the next 5 years, we're going to see a really big impact, hopefully using the monoclonals with the vaccines, looking at infants, pregnant women, adults, and somehow we're going to bring it all together and show a really marked effect. And that's going to be incredibly exciting. We also have some good news in tuberculosis. Remember that this is a persistent public health threat, second leading infectious disease cause of death in the world, and the biggest cause of death in people who are living with HIV. Some very nice recent data from WHO shown there. So we have, of course, we have a strategic plan for almost everything, but this is our strategic plan for TB, which has pretty, I think, obvious goals there. But I do just want to give you a sense of how many initiatives and programs we have. I'm not going to go through these in the interest of time, but with some of this work, the Gates Foundation, of course, has just launched a very large trial of what I hope will be a very effective TB vaccine. So between long-acting treatment drugs and a potential vaccine, again, 5 to 10 years, I think, is not an unreasonable time frame to see that we're really going to make a difference. I mean, these are ancient, persistent scourges. So if we can make a dent in TB and malaria in the next 5 to 10 years, I guess I can retire then and go birding. We also have a very interesting study in TB meningitis, but I'm going to not go there just to tell you. And the last thing I'll say, I cannot, of course, not mention HIV. I didn't want to focus on HIV since so much of my work has been focused on this. But I will just say that we are not winning the war against HIV, particularly in the US. You know, again, I lived 7 years in Alabama. I can't tell you, every time I was in service, I saw several young men, mostly young Black men, mostly young men who had sex with men from rural Alabama, who basically came in with late stage lymphoma, toxo, PCP, and it was just like being back in the 90s, you know, talking to their families and having their families say, well, it's, you know their lifestyle, right? Shame, stigma, lack of access to biomedical prevention, need for an HIV vaccine, need for a cure. I can't really say how committed I am to this. It's going to take a lot of time, but again, I think we can get there. There's some exciting, cautiously exciting, I think, news in the HIV vaccine field. So again, we can talk about that if we have time. And then the last thing that is very concerning, and of course everybody's experience, is climate change. The one thing I will mention is that climate change has an effect on ID in a lot of ways, and there's a very nice, depressing report there called Climate Change and Epidemics that if you're interested in, I strongly recommend. It's a little wonky, it's a summary for policymakers, but it does give you a sense of all the ways between vector spread to migration driven by people who need to move because things are getting too hot, to things that are happening to the environment, destruction of habitat plus extreme climatic events. So it is not a good situation. The last thing I'll say is that we are doing a strategic plan. Now, I'd like to say this is not your father's strategic plan, but I don't want to be sexist or ageist. What I want to say is that some people do strategic plans. We all know strategic plans. They come out with beautiful glossy brochures. They're pretty. People make slides out of them, like I have several times during this talk. But I really want this strategic plan to be a game changer. I want input from people. I want you to tell me what you think. We really need to hear from people invested in taking care of patients, in doing the research, in getting funds, in thinking about the future and how we're going to combat some of these challenges I've outlined. So what I am committed to do, we are compiling input until May 27th. We are then going to have a big sort of leadership meeting, and I'm going to report back this summer on what we heard from the community and how we are going to respond. So we will generate a nice brochure, and you will be able to, you know, show that on your coffee table. But I do want people to know that we're listening. I want to hear what people have to say, and please reach out to me. You can do it through the RFI or what is it? I forget what it's called, request for information. But anyway, whatever you do, please talk to us. So with that, I will say thank you for this amazing opportunity and look forward to spending the day with you all.
Thank you so much, Jeanne. One quick announcement before we move into questions, which is that recall infectious disease people, faculty, fellows, students, stick around for the pictures at 9:15 on the steps afterwards. Please don't run away. Okay, now questions. Oh, that is blending.
It's not that bad if you stand over here. Oopie.
Thanks, Jeanne. That was great. And it was great to see and hear about your history, personal and professional, and your path to leadership. And a lot of young people here. So maybe some thoughts about how you think about, because I think it's really easy to get sort of demoralized, right? From geopolitical issues or other, and sort of say, I can't make a difference. I'm not going to try. So what words did you have for yourself and your family as you sort of thought about transitioning from UAB to NIAID, and sort of what words would you have for all of us? Thanks.
So I don't usually do this, but I am going to tell you I gave a talk at the New Investigators Workshop at Croy. And that was the topic of my talk. It was really about, and I'm happy to share the slides with you or send you the link. It's a quick talk, it's like 20 minutes, but I really talked mostly about my failures as an investigator and getting over them, and why, you know, it's a little bit of what doesn't kill you makes you stronger, but sometimes it does kill you. And you got to figure out how not to die. It's like a video game, right? You just got to pick yourself up and really sort of, you know, recognize that if you have a commitment and a passion for science applied to making things better, whether it's through political advocacy, scientific advocacy, whatever, you know, we really need you. We can't afford to let anybody get off this boat because we just, again, I showed you the numbers, but even more than that, we just need a real consensus and a mass of people. So I guess the way that I stayed in it was trying to keep my eye on the prize, which was making a difference. And the longer you're in it, the more you realize that, you know, there is attrition, right? So you're sticking around and you've got things to say, and you really can make a difference. So I could say a lot more about that, but I would just say, don't get discouraged. The other thing is, take a look at the New England Journal editorial from a couple of months ago now on mentors, on being a mentor. It's a great article about what you need in a mentor. And I love the last line. It's something like, after meeting with a mentor, you should feel grounded but light as air. So make sure you find good mentors, you know, and you're not always going to be assigned good mentors, right? Sometimes mentors just don't work out, or they don't speak to you, or you don't speak the same language. It doesn't mean you have to abandon them. You just can find lots of people. I certainly had to do that because there were people in Seattle who didn't really think what I was doing was very interesting. I can tell that story another time. So I just found other people who I think had faith in me, who knew I wanted to make a difference, and who thought, you know, wow, that's scientifically really interesting. That's so cool that you did that. And I remember hearing that from people and thinking, well, maybe I'm not that clueless after all. So really just be open. Don't hesitate to reach out to people, and you know, don't beat yourself up because it's hard. It's tough out there. Deciding to go to NIAID, that's a whole other conversation, but I will say that I really couldn't pass up the opportunity to hopefully make a difference in a completely different level. So maybe we could talk about that later today.
Dr. Mary.
Well, I enjoyed your talk very much, and I specifically have a question about your work. The specific question is, are there any anatomical changes that accompany the bacteriological changes that you've been looking at?
Fantastic question. So I sort of alluded to that, Dr. Merigan. So people have done, you can imagine this is a little bit tough, but with, I think, better sampling, we're getting closer. It's hard to characterize the cervical immunologic interface without getting invasive, somewhat invasive tissue specimens. So we used to ideally want cervical biopsies. Some people, especially in Julie McElrath's lab, have really now gotten much better at using cervical cytobrush and other things to try to characterize what's going at the cervix immunologically. When you say anatomic, what I would say is that there are immunologic changes at the cervix that are almost certainly driven by some of these anaerobes and or driven by what Lactobacillus crispatus is conferring. And people have isolated specific proteins that are related to Lactobacillus crispatus that elicit more protective local immune mucosal reactions or responses that are then gone with the absence of the lactose and that are taken advantage of by some of these anaerobes.
Do you think that if you could monitor the patients, there might be a HPV change in susceptibility as well as the HIV?
It's a great
change?
question. And that has been suggested by some of the cohort stories for sure. I think the hard thing with HPV is getting people at the time of acquisition, because you're trying to look, because first of all, as soon as people start having sexual contact of any kind, they start getting HPV. So it's hard to get in there and study that before that happens. And secondly, you're dealing with multiple types, but I'm almost certain there's a relationship there. The other anatomical thing I wanted to mention, I didn't talk about, is the biofilm. So bacterial vaginosis is a biofilm disease because when you do vaginal biopsies of the vaginal epithelium, you see this unbelievably dense biofilm that is populated largely with Gardnerella vaginalis, but also a bunch of other anaerobes. So one of the theories for why we can't get Lactobacillus crispatus back in there to colonize is because you first have to disrupt that biofilm as well as reduce the anaerobe burden, and then maybe you can go in with your probiotic. So that's why I think these probiotic studies are a little bit simplistic and need to think a little bit more carefully about mechanisms. Thank you for asking me about one of my favorite topics.
Okay, thank you so much. I think we're a little over time, so I think we're gonna call it here. Thank you so much, Jeannie, for a
Thank
really
you,
wonderful
everybody.
talk.
Thanks for showing up.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.